Okay, by my clock, it is now time to begin the meeting. So, out of respect for all the people who are online, let's do that. This is the LAMP session. Remind everybody about the IETF note well. This talks about your rights, privileges, and responsibilities here. So please don't contribute till you know what those are. And please treat each other with respect and keep the discussions about the ideas, not about the people. We have a very long agenda. Fortunately, some of these topics are just nothing changed since last time. We just want to make sure we keep them on everybody's radar. But there's 4 slides of agenda. Those were sent out numerous times in the last month running up to this meeting. Are there any agenda bashes? Okay, then we'll quickly, basically it's broken down into the categories of things that have already moved off to um, uh, completion. Those are just so that everybody knows those 2 RFCs finished. Then things that are with the ISG or the RFC editor. There are a couple things to talk about in that group of documents where comments have been received that need to be addressed. And then there's a whole bunch of PKI related documents. And then there's a whole bunch of SMIME related documents. And then there's some documents that we are thinking about adopting. So that's the order we'll take them in. And unless there's any further questions, we'll get to it. Okay. Let me. Oh, it doesn't keep the order when you do this. Which one's next? Can you tell?
Oh,
It's
yes.
is it lightweight?
Algorithms is first off the top of my head.
Okay, Hendrik, do you want to drive?
Yeah, good morning, everybody. So this is a quick update to the CMP algorithm, CMP updates, and lightweight CMP profile drafts. Next slide, please.
Thought I gave you control.
Yep. So CMP algorithms is approved for a while already. Finally, it's just waiting for ACE CMP over COAP draft because they come in a bunch. There is one minor thing to be changed at auth 48. CMP updates status is the same. Also, 2 things to be updated during auth 48, which were discussed on the mailing list already. And the lightweight CMP profile, there was one final comment from the IESG reviews, and an update was provided in, I think, January, which closed this comment as well. And all 3 are waiting for publication in the RFC editors queue, mainly for CMP over COAP to be released. That's it. Thanks.
Any questions for Hendrik? Okay, the next item on the agenda is 3709 BIS. Nothing has happened with it yet, so there's nothing to report. Now we're going to move to 4210 BIS. As soon as I find the slides in this long list.
Yeah, here we are. It's me again. First, I'll start with 6712 bis. So this draft is more or less complete. We moved it to GitHub to ease commenting and discussion, but there is nothing to do and no major changes since IETF 115. The 4210 bis is also complete with regard to the changes performed by CMP updates, but there are changes in the loop with regard to adding CAM support, so CAM key support. We added the section on proof of possession for CAM key using the indirect proof of possession, and we provided a proposal for support using CAM keys for message protection. So it's mainly MAC-based protection with a key provided by CAM mechanism. So as discussed in IETF 115, we provided version using HPKE. This was a version 04 and 05 of the draft, but the authors discussed in a group of also with others to also provide a version using a plain CAM and KDF, as it is also done in the CMS based in the CMS draft from Russ and John. And we feel like this is a more straightforward way doing it. People can see this in the draft 06. We also moved the document to GitHub, so people can also are free to raise issues there and see the work progressing. Yeah, so this is one slide on the pros and cons for HPKE versus using plain CAM and KDF. As said, we see this as a more straightforward approach because we do not need confidentiality, we do not need seal and open from HPKE. We mainly establish a shared symmetric key, a shared secret key to be used then with MAC-based protection. The second point that I would like to raise is in the draft we propose kind of a symmetric way, is assuming that both sides, the client and the CMP server side, have a CAM key and both contribute to a shared symmetric CAM key. So initiating both or using both their CAM keys to have a shared secret and then deriving a joint shared symmetric key from these two CAM keys to be used on both sides for the MAC-based protection. But while discussing this and yeah, having a first draft in the document, we feel like we have more flexibility if we just describe how to establish a shared secret key for one side if one side has a CAM key, and then leave it open whether the other side also uses a CAM key or uses a signature key, so that we have a more asymmetric approach, just specifying how to establish the metric key for, or a shared key for the client or the server side. Of course, it can be used if both sides have a CAM key, but it is not needed then. So looking at the two approaches, so this would mainly be the approach if we establish a joint shared secret key, where we take the two shared secrets, SS1 and SS2, coming from, so can I point here? Do I have a pointer?
I don't think so.
I don't think so.
I don't think there's a pointer.
Okay. Then this
Because it's being
results
shared from
in
my machine.
then we result in one shared symmetric key that is used on both sides for the MAC-based protection. And in a second approach, we have two different shared symmetric keys if we assume still both sides have a CAM key. And they are used differently, so the SSK1 and SSK2 on both sides. But this approach could also be easily used if only one side has a CAM key and, as said, the other side has a signature key.
So I would really like a lot of review on this part because it's all very, very new. So please, if you only have a little bit of time to review 4210 bis, please spend it on this. Sorry, back to you.
Yeah, thanks, Russ. So I really appreciate any reviews and comments, of course. Right now, we have the approach with this establishing of one shared secret key. The question is, I would also like to provide the second approach, just specifying it for one side, and which could then be used either on the server or the client side. The question is, what do others feel? Is it adventurous to go down that road or not?
Anybody want to offer any feedback at this point? Or if not, please take it to the list.
Okay, so then I will take it to the list, and we can continue there.
Okay, is this your last slide?
That is the last slide. Okay.
Are you okay?
I'm done. Thanks.
Okay, thanks. Sorry, Mudiko threw me out. I'm having to get back in. Which one's next?
Here's the agenda.
That was 4210. What's next?
4210, 6712 bis.
He did that already.
Okay, PB Mac we don't have, right?
Right. Is Hubert with us? We did not get any slides for PB Mac 1. No. Okay. Then no update on that.
7030 CSR headers.
Is Michael Richardson with us? We did not get any 7030 slides. Anything to share, Mike or Michael?
Hi. No, I thought I sent an email. In fact, I have no update.
No update.
Didn't send anything.
Okay, thank you.
Sorry.
Next.
Carl and Sean key attestation. No.
Okay, no update on that.
Dilithium certificates.
Do we have slides for those?
We don't have slides for dilithium.
Is there anything?
Oh, yeah.
Dilithium certificates, we didn't get any slides there either. All right, then it's Kyber certificates. We did get slides for those.
Hello.
Turn it on.
Testing. All right. Hey, it's me. I'm Sean Turner. So I finally updated this draft. Next. So before this was a whole, it was going to be all of the chems, and since they picked one, we're just going to do Kyber, and I put all three in there. So it's basically, instead it was like, hey, we're going to have all these places where we're going to list them all. It's just about Kyber. We started to add some ASN1 to actually make the draft a little more concrete. And we started to add an applicability statement to basically give people a warning like, hey, these aren't really TLS certs. The number of times that I've had to explain to people that you don't use an encryption certificate to set up a TLS session is staggering. So this is kind of like, hey, until those other things actually get done, you can't use it there, but you can use it over in CMS and maybe elsewhere. I don't know if PGP would even use this stuff. DKG gives me the sideways look. All right, next. There's only one.
So
Yeah.
Sean, should you be saying Jose and Cozy as well?
Yes, if they wanted to use certs, sir. Yeah, I made the same face DKG made. So I got to make this a little bit of audience participation here. So you can't see this?
Oh.
Is it possible to do the
Ah.
Oh.
We shouldn't mess with the lights.
Yeah. I agree.
Well, luckily, so in any event, you can go look. So, all right, I will update the other slides because I use the same font, so we'll fix that. So this is the.
So is there a system where people could download these slides?
Is there? There might be that. There might be that as well. So
Repeat that since like he doesn't know.
so there's a way to download the stuff out the data tracker off the agenda if you click through the slides. So.
Or off Medica.
I apologize for the slide color and the font color, but basically the key is that we, Boz made a little script so we can actually put examples in the draft of public keys and private keys. And, you know, Jake was like, hey, that's great. Why are these extra wrappers and octet strings stuck at the front of these keys? So I went and looked at RC 8410 and what the X525519 people did, and they didn't have any wrappers. And so what they did for the key part, which is the public key, they put no wrapper. So I was like, oh, that we can do that. And then we looked at the private key definition, and it also had a wrapper. And Jake was like, what's that for? And I was like, well, that's because what we did in the past. And he's like, do we have to keep doing that? And I was like, I don't think so. Now, this might seem weird because these keys are huge to save a couple of bytes here and there. But if we don't need to expose the syntax, let's not. Just leave it all up to the HSM and then whatever. And, you know, it's not like the elliptic curve private key where you had to spend like a page explaining that the first byte is a 0 or 2 or a 3 and it means this, and it tells you what the other side is. So we're hoping just with no wrapper. So the ASN1 experts in the room, take a look at this in the draft and tell me if I did this right. And then I know Russ uses a lot of tools that we can check to make sure it actually compiles and makes sense. And then we'll get Boz to update a script and actually get some examples stuck in the draft. And then there's really not a lot of questions. The only thing that's really going to be left is the private key format, which is not really an interoperability thing, right? Because you usually store it locally. So we'll have to have an argument or discussion, I guess, about how much and which parts you need, because apparently you don't need to send all of it. And the same thing with the dilithium certificates. It's like how much of it to send. And the thing is for larger devices like your laptops, it's not really a big deal. But for IoT, it's kind of is a thing. So we have to kind of figure out the right kind of balance there. Deb.
So I've not looked at this, nor have I looked at Kyber. But if classically for encryption sorts of things, we generate stuff in the back end and jam them onto the clients. In that point, the private key format matters because I have to generate it and give it to you, and you have to be able to handle it, right?
Right. So Deb, what he's saying is he wants to just have a raw string here, not an octet string around it. So it'll just be an octet string.
The simpler it is, the better.
Good. So we're
on the same page.
Same page.
Yes.
Awesome.
Completely fine. Just don't say it doesn't have interoperability issues.
Fair enough. I take your point.
Mike.
No.
Probably a switch somewhere.
There is.
Is this on?
Yes.
Do you have an opinion, either you like or you conflict with or you're compatible with the QSC, unique QSC keys draft?
Yeah, no opinion at this point.
No opinion.
I hadn't looked at it, to be honest.
Like someone in the room probably knows the answer. Like, they specify a public key format? Does it just slide cleanly into your wrapper, or are you specifying a contradictory format?
We're for the public key, we're providing no structure. It's just a straight up bit string. There's nothing. And so we're basically proposing that for the private key. Because the weird thing is the way the construction is, those fields tell you how to bang it into another structure in the private key format out of PKCS 8 or whatever, right? So that's already an octet string over there. We're just saying, put that value straight in the octet string. Don't put another wrapper in front of it. Just dump it directly in there. So it saves a little bit.
So for example, what he's saying is with an RSA key, it's a sequence of the modulus and the exponent. And so you have to DER encode it to get the octet string. And here he's just saying there's nothing. It's a raw, just there's no ASN1 structure to the key itself.
And I'm trying to be like the cool kids, the 255519. So I'm trying to do what they did. my beard is way too white.
You're too old to be cool.
Thanks, Paul. Roman? Yeah.
No, I wanted to finish. I have a meta question related to this, so I want to make sure we caught all the feedback about this, if anyone else has anything more to say. We're good? All right, so my meta kind of question is that I think with perhaps this and some related things, I've been hearing kind of questions, we don't want folks to roll their own, do kind of something janky, so we got to move fast. So kind of meta question, are we trying to hit a particular kind of date? So, or how quickly can we move this? I mean, can we accelerate the pace of this?
So the idea is that we will have everything except the object identifier figured out. And then when NIST publishes, they will assign the object identifier. We'll fill that in HIT pub.
And the sneaky thing here is like between Boz and Jake, right? They got input to large code bases. And so when they're like, we want to get rid of that and we can change it, I'm like, oh, that's great. Let's do that.
So is there a slate of early code point allocations kind of coming my way that I can help with?
No,
because NIST is
right, because we're waiting for NIST.
So I'm hoping. So in adding the ASN1, what we'll have is a module that people will be able to compile. There will be a couple of TBDs, and if you want to pick 99, the whole thing will compile, and then you can run off and test and knock yourself out. So we're kind of okay. Cool. Next slide. There is one more, I believe. All right, to do. Add the examples. I want to get clearance that seemed like a good thing. I didn't hear anybody jumping up at the microphone and yelling at me. So we're going to go ahead and get that done. And then what we're doing is we're waiting for NIST to finish. The polite thing is what we're going to do is, add some references to their modules and use their OIDs and kind of call it a day. Of course, the impolite question is, when are we going to get them? I know it's a little bit of a loaded question, and it's like sometime in 2024. John.
Yeah, I was just going to say you can join our hackathon team and do some testing with that even before there's OIDs, as we can define some, pre-OIDs or whatever just for testing.
Awesome.
Get it working.
Awesome
well,
sauce.
Those are just placeholders.
Yeah, we can use the placeholders that are there.
That's awesome. Awesome sauce. The only other thing that I've heard is apparently Kyber might not be called Kyber at the end. So we're kind of just, I didn't actually know that till last night. So apparently I'm not that far in the know. So the whole draft name will change at the end, but I think that's perfectly fine. It's just, it's kind of what people call it now. And when they come out with their final name, the who's he was it algorithm or whatever will adopt.
No, it'll have a cool NIST name, like advanced,
I feel like I remember when the UK tried to name an icebreaker and it was Bodie McBoatface was the name of the thing. I feel like we should do the same thing for this algorithm because I think it would be the stuff these crypto guys could come up would be super cool. So let's put that in. All right, thanks. Thank you very much.
Remember, Kekak became SHA-3. Which one's next, sir?
It is now time for multi-auth.
Who's talking to multi-auth?
Yeah, I'm talking to him. Okay.
All right, hi, Allie.
If not, I'll just talk anyway. Oh my God, I'm so short. Okay, can everyone hear me? Cool. So we're just going to go through, since this was just adopted, some updates to it when it was posted, and then a couple of suggestions from the list. So next slide. Thanks. Cool. So the things that we changed from when it was a draft to the 00 version are, it was like the first one here, the language was just a leftover typo. So the extension is just a hash of the entire cert. It's not a list of entries anymore. So thank you for whoever caught that. And then the language here, we loosened it up a bit for the URI, switching the normative from should to may. So it's not as, fierce. And then a lot of nits split the references into normative and informative. Okay, next. Cool. Okay, so there were some open questions kind of left over from the list that we thought would be good to discuss after adoption. Currently in the CSR attribute, we're using binary time for freshness because it's a nice compact representation, but there was a suggestion that maybe we should use date time or UTC time instead, which is fine. I think, we don't have any strong opinions regarding that. So if anyone does, that's great. The other thing in the attribute is that we're currently using issuer and serial number, and so that's what's being signed over. But there was a suggestion to sort of balance it out and make it similar to how in the extension we have a hash of the whole cert, just putting that up in the CSR as well. And I think, that's a good suggestion. If there's strong opinions on that, I think that makes sense as well. The last thing is that, so currently we have the hash for in the extension, the certificate that's hashed. We use the same one that's used to sign the cert. We did that from it was a suggestion or comment from NIST. And it kind of makes sense since the cert and the extension are being created at the same time, just to use the same hash. But there was a suggestion to maybe add a field for algorithm identifiers so that you could use a different one if you wanted, just to make that more flexible. I think we had that in an earlier draft and then changed it. So also an easy change. So if there's a strong opinion on that, I don't think that's a big issue to change either. All right, next slide. The last thing is more of a structure suggestion. So right now the whole document is written from the perspective of looking at, getting a PQ certificate and then adding in the related certificate of the traditional one. And that's how the whole thing is written in that language. So there was some interest in sort of generalizing that. So it's saying here you're trying to get a new certificate A and you have certificate B that is related to it. So kind of loosening up that language. And then we would add the example in the back end of the document specifying, okay, if you have a PQ cert and you want, that's the new one being issued and you have a previous traditional certificate, that's the related one. So sort of forcing that example at the bottom and loosening up the language to be more general in the rest of the document. So just wondering if the group sort of wants to go that direction and make this more general for different use cases so that you can apply it in different ways. And that is it.
Okay, I have a quick suggestion about on slide 3. If you look at the ASN1 for OCSP, you will find how to deal with this hash thing so that only when you're not using the default do you carry.
Oh, got it. Yep, I know
Okay.
exactly what you're talking about. Perfect, cool. Yep.
I can't find where I got to log in. Hey, this is Sean Turner. I think this is the audience.
You have to log in. Or you're not
yeah, whatever. So I'm Sean Turner. I will do it eventually, right? It's somewhere in here. In any event, this is the audience participation part. I thought I would get up. So I see the point of maybe generalizing it, but it seems like a lot of work because then you're going to have to write another draft to be like, oh, hey, here's the PQ thing. Just do what it's meant to do and be done with it. If there's another way that would be generalized, okay. I just feel like it's probably a lot easier to just do what you said you were going to want to do it for and be done. That.
Any other questions? All right, thank you.
Easy crowd.
Header protection.
Hello. So talking about cryptographic protection for email headers for end-to-end encrypted email. Next slide, please. Just a little recap of the things that have changed recently. The header confidentiality policy minimal. Sorry, let me just give you a brief overview of what's happening here. I think the end of this presentation, you'll find me asking for working group last call on this draft. So if you have not been paying attention to this draft for the last years, you probably should start paying attention. Updates for the most recent changes. This I think happened at the end of the last IETF, but the default header confidentiality policy is HTTP minimal. That's the recommended default. Which means that basically you will be, when you encrypt a message, you will be encrypting the subject and you will leave the other headers visible on the outside of the message. That's for deliverability purposes and just to make sure that the things that the user probably most thinks of as content are most likely to be protected. We say that mail user agents that implement this must be able to generate and interpret the injected headers strategy. If you recall, there are two schemes. There's an injected header scheme and there's a wrapped message scheme. The wrapped message scheme is more similar to the thing that was standardized in SMIME 3.1, but had very few implementations. So you may generate wrapped messages and you must be able to interpret them. Note that the wrapped messages scheme, so the injected header scheme, you have to be able to do if you want to implement this draft. And you may include this legacy display element in the body so that legacy decryption capable mail user agents can still see the subject line that had been hidden by HTTP minimal. If you're generating a wrapped message, we have now changed the recommendation in the draft. Instead of using this forwarded equals no business, we're using protected headers equals wrapped so that the recipient can identify that that is what you're trying to do. That aligns it better with the injected headers mechanism, which used instead protected headers equals v1 as a parameter to the content type. And finally, we added this HP removed and HP obscured headers that enable the recipient to tell what the sender thought they were protecting in terms of confidentiality when they receive a encrypted message where the headers are included inside the cryptographic envelope. That makes it easier for receiving mail user agents to deal with these things without accidentally leaking headers in reply that were not leaked on the inbound side. Next slide. So a little more detail about the two different schemes. A reminder here, the injected header scheme basically says, so the goal of the injected header scheme is we want these messages to be as close to standard messages for the recipients as possible. We want to provide as few weird artifacts for the recipients while still enabling cryptographic header protection. So for signed only messages, it is 100% compatible with legacy mail user agents. And with an encrypted message that does not attempt to hide any of the headers, but just still wants to preserve the signatures over those headers, it is also 100% legacy compatible. If you have an encrypted message which does hide some user-facing header, like the subject, then a legacy mail user agent is unlikely to be able to render the actual subject of the message. And so when you are generating such a thing, we have this draft defines these legacy display elements that you inject into the body part of the message that the user is most likely to read. And those are well-defined. We think they are deterministic in terms of how you can generate them and how you can detect them on the recipient side. You can generate this injected header scheme without any risk. Next slide. The wrapped message scheme is a little bit riskier to generate, and I think that's one of the reasons that it was never widely adopted. When you generate these things, legacy clients tend to kind of choke on them, or they present them as a forwarded message, or they present you with an attachment that you have to click on to open, and then you have to deal with the attachment. So it's a little bit more clumsy. We have some attempt to work around this to make it possible for non-legacy clients to deal with them more smoothly, like the signaling protected headers equals wrapped, and content disposition inline recommendations. But we do recommend that you generate the injected headers variant instead of the wrapped message. Next slide. So as I mentioned, the header confidentiality policy, we define a language in the draft that says, here's how to decide which headers to hide if you are encrypting a message. You don't necessarily need or want to hide all headers, and if you do, you may run into deliverability problems. The language for header confidentiality policy is designed to encourage mail user agents to developers to talk to each other and say, hey, I'm using this new confidentiality policy and I'm not having deliverability problems. You might want to try it. The draft defines 2 HCPs. One of them is HCP null. You can imagine what that does. Doesn't hide anything. And HCP minimal is the recommended default that only hides a subject header. With this draft in place, as an RFC, we hope that future mail user agent developers will propose alternate HCPs that they can document what the side effects are. Next slide. When you get a message that has cryptographic protections for its headers, this draft gives you guidance about what to do with those headers. It helps you to think about the cryptographic status of those headers, and you can infer the sender's header confidentiality policy by looking at these HP obscured and HP removed headers that show up inside the cryptographic envelope. That's useful if you want to do things like reply safely to encrypted messages. So please take a look at this if you're working on a mail user agent. Next slide. We have retitled the draft. It was header protection for SMIME. Nothing in the draft is SMIME specific. It will work for PGP-MIME as well. So the new draft title is Header Protection for Cryptographically Protected Email. The draft still focuses specifically on SMIME. All of the test vectors that are in the draft, and there are many, if you'd like to take a look at them, are SMIME test vectors, but none of the mechanisms depend on SMIME. They are abstract and they work with any MIME encapsulation mechanism. Next slide, please. So we hope that this can get into working group last call. We hope it gets published as an RFC. There will still be future evolution because the email system doesn't, the ecosystem doesn't stay still. Some ideas about what will happen in the future. We'd like to see if enough of adoption happens, you can not add these legacy display elements anymore because you can expect your recipients to be able to render the injected headers properly. That would be nice. It makes it a lot simpler to generate a message if you don't have to think about injecting these legacy display elements. We want folks to start thinking about how do you render a message to the user when the headers are not protected. If we expect emails to come that have cryptographic protections that can have header protection, then how do you tell the user if they've received a message that doesn't have the adequate protections? You know, we had this problem in HTTPS where people will visit a website and some parts of the website were HTTP and the other parts were HTTPS. Took us years to get that solved, but we pretty much have gotten it solved, right? You had the lock with the slash through it. That was a warning signal. People heard about the warning signal. It got back to the website developers. They changed their websites. People don't do that so much anymore. So, and maybe the behavior will be slightly different, right? We have this secured context in the web. Maybe your mail user agent will behave differently if the headers were not protected. So we think that there's opportunities to evolve to make things not only simpler, but safer. There's some additional nuance that was in the draft that's been moved out of the draft into the end-to-end mail guidance draft, which I will talk about in the next presentation, I think. I didn't see it in the slides list, but hopefully that'll be coming next. And we hope that the header confidentiality policy, the language that's described there, which is fairly simple, will help people to think about increasing the confidentiality protections in the future. Next slide, please. So, as I warned you ahead of time, we are, as the authors of this draft, Alexi and Bernie and myself, are asking the working group to put this into working group last call. Or maybe we're asking the chairs to put it into working group last call. I don't really know exactly how that works. But we think it's ready to go. And if you haven't looked at it yet, you should look at it now. I think that's all I got on this one. People have questions?
Does anyone have questions or concerns about going to working group last call? Okay, Alexander.
Yes, I'm Alexander. And I just have a remark. You asked about the usability aspect of how to visualize different types of messages. normally this would have to be carried out through usability tests,
Absolutely.
interviews and evaluations, and it normally takes time to do this right. So I think it's reasonable to keep it out of the RFC itself, because if you try to do it fast and squeeze it in before it's over, then you may not have a perfectly usable solution.
I agree with you. That's absolutely right. We need that kind of work done. It's not going to happen in this draft, but hopefully this draft will lay the groundwork to give people something concrete to test for their usability studies.
All right, thanks.
Thanks.
Hi, it's John. Yeah, I was just wondering, you mentioned about email users or whatever, if they come up with their own header types or whatever you were mentioning, and they would need to document that. Is there going to be an easy way to do that? Because I could see, I mean, different companies will do different things, and one might reinvent the wheel and another one's doing something else, and then,
You said header types.
or whatever.
The header confidentiality policy?
Yeah, whatever, that thing that you had underscore null, and then you had to define the other one that does something, and then you said that, vendors might do other things, or we expect them to document that, but is there going to be like a registry or some standard way that they can do that?
We are not currently contemplating a registry. Our hope is that people can publish a, if you're a mail user agent implementer and you say HCP null is unacceptable to me, HCP minimal doesn't do exactly what I want it to do, and I want to do something fancier, we hope that you'll just publish a draft describing the header confidentiality policy that you're using. If there's a massive proliferation of header confidentiality policies, yeah, maybe somebody should set up a registry for them, but I don't know that we need to jump to that right now. We don't have people knocking down the door to be like, I want to claim the name HCP 7 or anything. Yeah, but yeah, if people have insight, so I mean, the hope is the language is relatively simple, right? It's pseudocode that says, given this header with this value, what value should we put? Or should we remove it entirely on the outside of the cryptographic envelope? That's all the HCP is. And it just says, try to write it in this way because it's easy to communicate across mail user agents. We don't expect end users to have to make these decisions, but the developers should. So the goal is just to create a common language that developers can communicate. And we hope that that will happen in the form of internet drafts.
Okay. Hopefully that works.
Yep.
Alexander again, regarding the last point. I also wanted to ask about the registry, but he was ahead of me. I envision that it's possible that different developers will find their own names for configurations which actually do the same thing. And just like in this case of the QSC UniKey draft, which talks about one way to serialize keys, and then there are other approaches, these things can begin to proliferate, and then it would be more difficult to control them. So I think it would be reasonable to think of a registry in advance, because
I mean, if people want a registry, we can have this document ask Guyana for a registry, and the registry will be name and then reference, and the reference will point to an internet draft, and then we have some designated expert decide what they are. I'm fine with doing that. I don't think that should block working group last call. If that's the feedback from the working group, I'm happy to ask for a registry from Guyana here.
So I had a comment in chat about this particular issue. My personal opinion is the first RFC draft that wants to add a new HCP would be a great place to add in IANA considerations for a registry.
That works for me.
And you can say that in this document.
Okay.
Right.
I'll happily add that text.
Yeah. I mean, I think that kind of says, hey, if this idea takes off, then we need this.
Yep. I'll put that there.
Okay. Then we will start working group last call in a week or so, just to give everybody time to get home and get back on their normal time zone.
Okay. Do you want me to release a new variant that just mentions this thing about the registry beforehand?
Just think of that as your first comment.
Okay. Fair enough. Will do. Thanks for the feedback.
All right. Now we're going to the other email presentation, right? Not header protection.
So this is about the draft IETF LAMPS E2E mail guidance. This is about guidance for mail user agents that implement end-to-end cryptographic protections.
But if I could only find it.
The suspense is killing me, Russ.
You might have to refresh. I had to approve it right before the meeting.
Oh. Russ, you're sharing slowly. You should not be surprised The suspense is killing us.
Hey, I submitted these slides at least 10 minutes ago. So, you know, there's really no excuse.
But you know the content, so.
Yeah, well, I can actually ad lib on that. So one of the concerns about the end-to-end mail guidance draft is that the previous draft we just talked about, the header protection draft, actually refers to it and refers to some concepts that are in that draft. In particular, the cryptographic envelope and cryptographic payload that are described in that draft are critical to getting the header protection stuff to work correctly. So we risk that draft causing a we risk this E2E mail guidance draft becoming a misref, which could block the header protection draft from publication. I don't think that should happen. I also don't think that this particular draft is necessarily something that we're going to be like, done, we've solved the whole problem. Now we know exactly how to do end-to-end mail security. Next slide, please. So I'm going to talk here about some of the what's changed here and why, you know, what I think the strategy is going forward. So the recent changes, if you haven't read the draft recently, we added some guidance about dealing with BCC and encrypted email, which is an interesting, weird little corner case. When you send an encrypted email and you want a BCC, do you encrypt the BCC? What are the different ways? Like, if you encrypt the same message to the BCC folks, you might be leaking that there's an encryption to the target. So there's some nuance in there. We try to document those concerns. There's an additional section that talks about a very tempting implementation architecture, which is you say, well, my mail user agent already talks IMAP and SMTP, or maybe it talks JMAP, and you know, doing all the crypto stuff is kind of a pain to put it in my mail user agent. So what if we just stuff it in a little proxy that sits between my mail user agent and the actual IMAP, POP, SMTP, JMAP service, and let the proxy just invisibly handle all of it? Well, that'll be good, right? And there's a section in here that talks about how tempting that is and about what the problems are of that strategy, what some of the concerns are with that strategy that have to do with some of the trade-offs. You should read the section if you're interested in those trade-offs. Since 05 was released, there's a little bit of expanded, so we've expanded that warning about this proxy implementation to say, hey, it's not just about the mail protocol APIs, but using the mail protocol as a proxy, but any API that is similar that just says, you know, here's a message, do this thing. Turns out you actually need some knowledge about the state of the mail user agent to do end-to-end cryptographic protections successfully. So it extends those warnings about the proxy implementation to any comparable API. And there's some references added to the JMAP work because JMAP is thinking about this stuff too. Next slide, please.
So I just want to talk about the first bullet there for a second. There is guidance in SMIME about when you're using BCC.
Yep.
Basically, you're trying to prevent the recipient info headers from disclosing to the recipients who the BCC recipients are, because there will be a recipient info for them if you don't do a separate submit for the blind recipients.
That's right. And so the guidance is, you know, you're going to need to make multiple copies of this message and submit it to your mail submission agent, whatever protocol you use. You know, a different one for the folks who receive it in BCC than the folks who receive it not in BCC. And there's some even trickier things when you have multiple people BCC'd, because there is a question of, do you want each BCC recipient to know that the other BCC recipient has been BCC'd? So there's a little discussion about that and some guidance for what we think is probably a reasonable approach. If you're a mail user agent implementer and you've thought about these things and you think we've got it wrong, tell us. I'd love to get more feedback from other mail user agent implementers. So Bernie and Alexi, I'm currently the only listed editor on this draft, but Bernie and Alexi have given me good feedback on it. So I want to call out their help particularly. I'd love to get more feedback from other implementers. And then there's this issue about it being a misref for the header protection. The misref is when a document is missing a reference and can't be published as an RFC because it depends on normative guidance from some other draft that itself needs to be an RFC. Next slide. So here's what I'm proposing going forward with this. This is one of those documents that's never going to be done. So I'm proposing, there's still a large number of to-dos in there, mostly related to certificate management, which is a complicated thing. So I'm proposing, for the sake of avoiding the misref, to move a bunch of the certificate management stuff that we know needs some guidance, but we haven't had anybody step up to offer it, and I haven't had a chance to just tell you what I think is the right thing to do yet, to move a lot of that to a section that says, you know, this is out of scope for this document, but future work, future evolution of this should include, you know, should consider inclusion of certificate management pieces, move a bunch of those. So I'm getting ahead of myself with the slides here. But I want to make this a stable document. I want to shrink it down a little bit and aim for publication so we can ask for working group last call for this one too, so we avoid a lengthy misref. Rich, I see you on the queue.
Rich Sauls. Charles. Okay, whatever.
You're listed in the
yeah, I know. I'm
digital
looking at, I'm looking at the
surveillance anyway.
I'm
Rich
looking-
Falls. Oh, nice.
Yeah.
Rich, can I try Rich? Rich Sauls.
Okay. Anyhow, could you just repeat what the concepts were that would cause the blockage? Because I think they're kind of generic, and you could pick any other reference.
I don't think that. So the concepts that are causing the blockage is the cryptographic envelope and cryptographic payload that this defines. So if you read this draft, I hope some people in this room have read this draft. It says, when you receive or send an email message that has cryptographic header protections, MIME is super flexible, right? I can use MIME to give different cryptographic protections for different subparts of the tree if I want to, if I'm evil, right?
That's right.
Or I can use them, I can take an existing MIME message and repackage it. Anybody read the eFail draft? It's not an IETF draft, but the eFail paper. I can take an existing message and I can repackage it into parts of other things. And if a receiving mail user agent is willing to parse those things and say, oh yeah, it's totally reasonable to use MIME cryptography at arbitrary levels of depth within the MIME tree, then you can get these other negative consequences, right? So this draft says, look, you want a cryptographic envelope at the outside of your message. And everything inside that message is the cryptographic payload. And if you get anything other than that as a recipient, something's fishy. And if you're distributing a message like that, you're doing it wrong because you're going to trigger these other consequences. Right. So don't do that. We need those concepts, the cryptographic payload and the cryptographic envelope, the envelope and the payload for header protection. Because what header protection does with injected headers, it says stuff a copy of your headers on the payload.
Mm-hmm. Yeah, no, I understand all the background. I would say that if you do all those other things, then you render your message unreadable. But they seem kind of generic, and you could probably just point to, like, you know, the basic SMIME documents.
SMIME document doesn't say you should only do it this way.
I'm not saying, okay, so you're concerned not just about the definition of what the elements are, but the practice that's suggested in this doc. Okay, fine.
So
this seems like a good plan.
Yeah, Russ says it says that it's in the SMIME security considerations, but I haven't seen anybody take it seriously out of there. So
no.
I mean, I told you so. It doesn't help too much. Yeah.
Yeah. No. Okay. So it's not just the definitions that you're concerned, but the practices of the way to do it. And that this makes a lot of sense. Thanks.
Yep.
By the way, when we were working on privacy enhanced mail, this bit us, right?
Oh yeah.
It was before MIME was invented. Yeah. And because the feature we wanted was to put some plain text on the outside that a secretary would read and forward to an executive to make sure they actually read it, but the secretary couldn't do the decryption.
Right.
And where was that line? Right? It's always where's the line problem.
Right. Yep.
Hey, let me try this. Rich $. It's not working at all.
Oh, look at that.
Hey, so just for the record, I think this is a great way forward. Let's get it out there, get it done. If you just mark that section as, like, you know, non-normative or something, then it's going to sail right through. So I think, you know, always be closing.
Okay, next slide. I'll get to those details about what I'm specifically proposing here. So the current draft has a to-do for test vectors. I'm proposing that we don't include test vectors. There's a shit ton of test vectors in the header protection draft if you want to look at some test vectors for well-formed messages. And the wide variety of malformed messages we wouldn't want to put into a single RFC. So I'm proposing to say we're not going to do test vectors in this draft. I'm proposing to move most of the certificate management guidance, which is all of the current to-dos, into some sort of out-of-scope/future worky kind of section. And then there's a handful of fix-me's, a list of fix-me's. I know you want to know what they are. They're coming. But there's a handful of fix-me's that are left in there, and I'll either move those also to the future work section, or we can provide some simple text for some of them. And you can provide some of that simple text if you don't want the thing to be moved to future work. So next slide, please. This is the list of outstanding questions. So I mentioned that there's certificate management stuff. If you have any opinions about that and you want to take a look at the draft and say, I could fill this in, don't move that to do into future work, you can do it now. There's questions about how should you deal with indexing and search of encrypted messages. Got any suggestions for what the right way to do that is, or arguments about why, something you want to get people to take a look at? Put them in. Questions about how should you handle cryptographic secrets that require the user to interact, right? This is interrelated with the indexing. If you want to index your messages, but in order to index the clear text, you need to get the user to like press a button on their smart card. How are you going to do those interactions? How should your messages be deleted if you can delete them? What are the properties we want from secure deletion of messages? When you've sent a message, are there special ways that you should store it, or things you should do for storing the message that are different from what you would do to store a message that doesn't have cryptographic protections? When you validate a signature, should you cache it? What should you cache? How are the caches going to be useful? What are the things you can do to make that mail user agent more effective and useful to the end user to distinguish between a message? Maybe it's expensive to validate a message. I don't know how much it costs to validate one of these PQ signatures, but maybe you want to cache those things, and how do you protect those cached signature validations? Do you have an idea? If you do, submit it, suggest it on the list, pull requests on GitLab, merge requests on GitLab. Do you want to render to the user the cryptographic status of an email thread? Does your mail user agent have email threads? If it does, should you think about the thread itself as having a cryptographic status, not just a single message? When you're doing a draft message, I'm actually working on knocking this out because I think we should tell people what the right thing to do with draft messages are. I think the right thing to do is encrypt every draft message and encrypt it only to yourself, not to the potential recipients. There's no reason the potential recipient should get to read your draft until you hit send. Do most mail user agents do that? No. And actually, we already have some text for copies of messages that need to be moved to the sent folder. You could take a review of that and tell me if you think it's saying the right thing. So these are outstanding questions I'd love to get comments on from the group. But if you don't comment and nobody else steps up, they'll probably get moved to the future work section. I see folks in the queue.
Hello, good morning. This is Hai Guang from Huawei. I have one simple question: is what happens if user lost its secret keys? User can still decrypt the email received previously?
That's a great question. How to handle secret key loss? It depends on what you've done with the message when you first received it. It is possible to lose your secret key and still be able to decrypt your messages. For example, when you receive a message, you could store a copy in a symmetrically encrypted archive,
okay.
And then losing your asymmetric key, you could still access your symmetric archive if you stored a clear text copy of it. The draft doesn't currently contemplate that.
Yeah, is it possible to include some suggestions in your draft? Another issue is, in fact, for many users, they don't have the capability to manage the secret keys. So it's very difficult for them to understand these public key technologies. So it's, maybe we should think about how to make it easy for the normal user to use this.
Yeah, the draft has some mention of the challenges of dealing with key material. It may not have your suggestions in it, but I welcome suggestions for alternate text that should be there if you don't like what's there. Remember, this is a draft that is guidance for implementers of mail user agents. So it is deliberately designed to say this is not guidance for the user, this is guidance for the mail user agent implementer, so that the user doesn't have to think about the kinds of questions that you're pointing out users generally can't handle well.
Okay.
So yeah, this would be a great place if you have ideas or suggestions to include them.
Okay, thank you very much.
Thanks.
Go ahead, Deb.
Love this one, actually. So we have records management requirements, and how do you do that with an encrypted message?
Deb, can I ask you a question?
Sure.
How do you deal with record management requirements for encrypted messages?
So the answer is, unfortunately, you have to decrypt them and store them someplace else.
Okay. Would you care to contribute text?
Possibly. I have an answer to the draft messages.
Thanks. I appreciate the offer.
I think I've worked on this draft in the past. I don't think, I think anyway. So the draft messages issue is if you don't populate the to line or the CC line, then the draft can only be encrypted for yourself.
Right,
Because-
but what user composes a message and doesn't populate the to or CC line first? Well,
the
y'all are
hand still raised.
weirdos.
Hey. I've also never had a draft. Well, and I'm using Outlook and I am using SMIME. I've never had a draft message that I've saved to be updated later object that it doesn't have the public key for somebody I put on the to line.
Okay, so maybe Outlook is not doing it wrong. That would be great.
Maybe it's possible that Outlook is not.
Is it possible that Outlook is saving the draft in the clear? Because that would also cause no objections.
I don't think so. I have to check. And it's been a long time since I've looked at raw email data, so I could go and look and see.
Yeah, it can be tricky to dig into that.
Yeah. Well, yeah.
Thanks for. I mean, if you've got suggestions, I welcome the contributions. So yeah, thanks for raising those concerns.
I think the records management thing is not just a Department of Defense issue.
Oh, it's Sarbanes-Oxley. There's a bunch of regulatory compliance issues that are there. Yeah,
financial is all kinds of places.
Yep. Well, there's one more slide here. I don't want to take up the rest of the meeting.
We won't let you.
Yeah, good. So this is just a plea to folks in the working group. If this piqued your interest, take a read, give some feedback. If you have text for any of the topics that I mentioned, I encourage you to submit suggestions for how those should be fleshed out. If you're an implementer, you probably have some insights that bit you when you were implementing. You can share those insights and maybe make the whole ecosystem work better for everybody else. And if you know anybody who's working on mail user agents, please point them to this draft. If they're thinking about adding cryptographic protections, they might save themselves a lot of pain by reading it. If they're already done it, they might realize some things that they could do better. And if they know some things, then maybe they can contribute and help the whole ecosystem out. Cryptographic email is only going to work if the whole ecosystem works. And so we need to actually encourage other mail user agents to adopt the best practices. That's the point of this draft. So yeah, please take a look at it. I'm hoping to get this to working group last call by the next IETF with the strategy outlined here. And if you've got any suggestions, send them on to the list, to the GitLab instance, to me by private email if you prefer. I think that's it.
I think you got feedback
Thanks.
as we went. CAA is next. If I can find, there it is.
Morning, everybody. Corey Bonnell from DigiCert, here to present a draft. It's already been discussed on the list and adopted. Certification authority authorization processing for email addresses. Forgot to name my own draft. All right, next, please. All right. Yeah, so the base CAA specification in RFC 6844 and 8659 specify a couple property tags that are specific to domain names. So when you want to include a DNS name, in a certificate, and you want to restrict, I guess applicants want to restrict issuance processing, they would include one or more issue and issue wild property tags in their CARR set. But those are specific just to domain names. There is currently no standard right now for email addresses. Say, if, for example, you want to issue a certificate for SMIME, you want to include an RFC 822 name. In the SAN, right now, there's currently no mechanism to restrict to an allowed set of certification authorities. So on the list, prior to the call for adoption, there were several ecosystem participants that expressed support for this draft. We had at least one large email service provider state support. They also said that they had several large enterprises that also wanted to see this support added to the ecosystem. And then we also see that from a root, trust anchor management standpoint, several root programs also express support for this to add such constraints to the ecosystem, and also several certificate issuers. Next slide, please. All right, just some of the recent changes. So we added some guidance thanks to some suggestions on the list on the interaction of the critical flag and properties when a single CA resource record set contains properties that are for multiple certificate types. Say, for example, you have a SMIME certificate only issuing CA, call that Certification Authority A, and then you get all your TLS certs from Certification Authority B. Well, if those certification authorities don't understand the different types of property tags that they might not issue for, and one of those is critical, there could be an issuance failure, which would probably be surprising for a lot of the folks setting up their resource records. So we added some guidance in that regard to the draft. And then also just a couple small wording and consistency changes. Next, please. All right. So in terms of open items, I don't think there are any such so far. There was some conversation on the naming of the property tags, but I think that's since been resolved. And likewise, some discussion on maybe further refinements on the constraints. So, for example, if someone wanted to restrict issuance just to SMIME, encryption certificates or SMIME signing certificates, they could do so. But I imagine that, to keep the separation of concerns, that maybe we could, have this base specification that establishes the property tags, and then a subsequent draft could go and add those further refinements, and that would kind of more clearly delineate the work, I believe. But yeah, so if anyone has any comments, please raise them on the list, or here at the mic, I guess. Really, we'd want to hear the feedback. But absent to that, I hope that maybe sometime after this meeting we could have a working group last call for this. And here's a couple of the links to the data tracker, and then also to the GitHub repository.
Any questions or comments? Anyone have concerns about this going to working group last call? I think we'll do that in a couple weeks.
All right, great. Thank you very much.
CMS Kyber.
CMS, I almost clicked Kyber.
Okay. Hi, everybody.
Okay, over to you, Julian. You should see controls at the bottom of your screen.
Yeah, sure. Thanks. Thank you. Can you hear me? Yeah?
Yes?
Yes. Okay, great. So hello, everybody. Julien Pratt from Cryptonext. So I will make a short presentation of the updates on this RFC dealing with the use of Kyber in the CMS. So the latest updates actually are quite little, mainly two changes. So first of all, the title was updated because there was a mistake in the title. It wasn't even, it didn't mention CMS in the title, so it has been fixed. And the main change is about the way to carry the algorithm information in CMS. So basically, originally we used the quick key transport recipient information, but we switched to the KEM recipient info that will be presented by Russ later, so to carry the algorithm information. That's it. And a few words about the algorithm limitation. So now the draft only proposes three algorithm combination to encrypt the cipher key. So one for each security level, 128, 192, and 256. And the combination is given in the slide. And for the open points, maybe there are only few ones. So the new IDs to be defined. So there are 4 new OIDs. And maybe some details should be given on how to use the KEM recipient info in the context of Kyber, to clarify really the details. And maybe the ISN1 module should be updated accordingly. So maybe that's it for the updates on this draft RFC.
Hi, Julien. Mike Hounsworth. Can
Hey.
you go back to your crypto cipher suite?
Yeah, sure. Here you are.
So you have Kyber and the KDF is SHA-2, HKDF with SHA-2?
Yes, well, maybe we could switch to, we could also propose the shake-free, of course, but for the time being, that was, well, I was requested to only mention a small number of combinations, so we choose this one. Maybe we could also add the shake-free combination.
So I think this has been, I mean, recent discussions elsewhere, I think prefers KMAC when using PQC primitives. It's something we could discuss on the list at least.
Yes, please. Yeah, sure, of course. I'm open
Sorry,
to
Paul's
add
asking me to
any
say
new
more. What?
Say more on where are these discussions?
Right. So I'm an author of the Chem Combiners draft that's going to CFRG, and in that context, I think there's a preference for using KMAC with KMAC as the KDF rather than a SHA-2 based HKDF. So for consistent, does that answer your question, Paul? Yeah. So we should be consistent across the IETF about what KDFs we're choosing to use with Kyber.
Yeah, sure.
So I'm a little bit concerned about the null on the last row because I don't think Kyber provides any binding to the algorithm identifier. And so if you were to use null, you would lose that.
I agree. Actually, it was a request from a previous meeting. You know, I don't remember exactly who, but you know, the purpose was just to use the KEM output just as the key for the wrapper. But I agree that the use of KDF should be recommended. Yeah.
Yeah. Okay.
So do you have to keep it, or should I just remove the null algorithm?
I would love for you to raise the issue on the list and see.
Okay.
But anyway, it's a point where there's a difference.
Okay.
Okay, thank you.
Thank you.
Mike, you've got a hand up? Oh. There's no update on Sphinx Plus in CMS. Nothing's changed since last IETF.
Camry.
Ah. John, you're going to talk about KEMRI. If I can find the slides.
Hi, this is John Gray from Entrust. I'm here to present the new chem recipient info, and the slides will come up in again. Yeah, so this is the key encapsulation mechanisms and the cryptographic message syntax. Maybe we should have done this before Julian did his, because he makes use of this. And also a few other drafts make use of this. So this is work done with Russ Housey and Tomofumi as well. So we can go to the next slide, please. Yeah, so probably most of you know this. This is using Chem. Chem has three mechanisms. Obviously, there's your key gen. You generate your private key and public key. There's your encapsulation method that takes the public key, and then you get your ciphertext and shared secret. And then, of course, there's the decapsulation operation that takes the private key and that ciphertext and then you get the shared secret again, and that's how you can establish this common shared secret between two parties. And yeah, that's what we use to do this in the chem recipient info. So go to the next slide, please. So yeah, so in obviously in the way this is used with CMS, you have the originator side and you have the recipient side. So on the originator side, you have the content encryption key. It's the key that's used to actually encrypt your message. So that's pretty straightforward. And then what we do in Chem is each recipient needs to create their own key encryption key. So they need to make basically encrypt that in content encryption key. So the way they do that, and the way we do this, of course, is we use the encapsulate method. To obtain a pairwise shared secret and ciphertext for the recipient. So once you have that, so the recipient does that, and then once you have the ciphertext and shared secret, you use the KDF function with the shared secret to, and also some other user information potentially, if that's user keying information that can be sent. And so you use that to derive your key encryption key. And then, of course, the key encryption key is then used to encrypt the content encryption key. And then, of course, I mentioned already the content encryption key is used to encrypt the content. So that's essentially how it works on the originator side. And now we're going to go to the recipient side on the next slide. Yeah, so then on the recipient side, then of course, so now the recipient will use their private key along with that ciphertext that they received from the originator, and they will obtain the shared secret. And then, of course, they will run that shared secret again through the same key derivation function and any other information that might have been sent out of band as well to generate the key encryption key. And then using that key encryption key, of course, then they can decrypt the content encryption key. And then finally, when you have the content encryption key, then you can decrypt the content of the message. That's essentially how it works. And then the important structures on the next slide, which is the chem recipient information structure. If you know CMS, you've seen lots of these different types of things. So we have a new chem recipient info. It uses the same CMS version that's always used. The recipient identifier, those haven't really changed. What's new here is we obviously need the chem algorithm identifier that identifies the chem. So most likely this would be, for instance, in the draft we just heard about, this would represent Kyber, for instance. The chem ciphertext carries the ciphertext information. That's an octet string. Then you have the KDF algorithm, which could be any of the, I guess the KMAC one was the last example on the last one, but it could be anything that's specified. And then you also have the key encryption key length, which is the size of the key encryption key that you need. And then the user key material is the next one is important. We had a couple iterations of this without this. It is used in a couple of other recipient infos, but we actually, in our CMP 4210 BIS, we actually talk about using this as well. So it's basically extra information that can be added along with the KDF algorithm to derive the key. So it just gives you that extra bit of randomness. And then you have the wrapping, which is your algorithm identifier. So this would probably be like your AES key that's used to encrypt your key encryption key, or used to encrypt, yeah, the content encryption key. And then, of course, you have the actual encrypted content encryption key. So that's essentially the recipient information as an AS1 structure. And if you go to the next slide, I think that's all I pretty much have. Yeah, so if you could please review this draft, give us comments. Like I think I said before, it was just recently adopted. There hasn't been too much discussion about or controversy about this. It's all actually already being used by 4 drafts. So there's the RFC 5990 BIS, the 4210 BIS that we heard about from Hendrik this morning, our composite chem draft, which Mike will talk about later, is using it. And actually, and then Julian just gave us a presentation as well. That one's making use of it as well now. So, and one last thing is our hackathon. We actually had a message generated by David Hook that generated using this, and I guess Russ himself was able to decrypt that. So
other way around.
Oh, okay, other way around. Okay, Russ created the message, and David decrypted it. So we have some running code as well. So, any questions? I don't know if is this something where we could ask for
Hendrik.
Oh, Hendrik. Okay, thanks, Hendrik.
Thanks. So actually in 4210 BIS, we not directly use the chem RI, but we mainly use the content because we just derive a MAC key and we do not need the wrapping. But when we discussed this, we also discussed what about long-term security and forward secrecy in this. So if at some later point in time the private chem key is compromised, do we have any, or did you think about adding some ephemeral key to the structure, or this is not a topic of CMS?
We did not talk about adding an ephemeral key to the CMS. I don't know. Well, yeah, I guess it is ephemeral and that it's generated for each recipient on the fly. So in that sense, yes. Okay, that's an ephemeral.
Question for Russell and Clara, or anyone in the room who's an expert. Does CMS do forward secrecy? Like, isn't being able to decrypt your messages way later like an actual property of CMS?
Yes and no, right? I mean, the idea is that, for example, the UKM is used for key agreement to make sure that when you are using the same key pairs, Diffie-Hellman key pairs, you generate different keying material for each of those messages. So it's used for diversification. I wouldn't say PFS.
Okay.
Jonathan.
Go ahead, Jonathan.
Hi, Jonathan Hamill. I appreciate having in the examples that you have the stepwise like constructions of them, but the final result of the content info auth envelope data is just in an ASN1 dump. It'd be helpful to have the textual encoding as well, so we can actually verify it in implementations.
Okay. You mean like base 64 blob?
Yeah.
Oh,
okay.
Sure. No
So you
problem.
mean put that in the
I have
draft?
it. I just didn't put it in the doc.
Yeah. Okay. Okay, we can do that. So any other questions? I guess, is that the point where we asked for working group last call? I don't know. I mean, it's still pretty new, but
this is really new.
Yeah.
I mean, Corey's draft is pretty new too, right?
Yeah,
So,
but it's like
so we can let it distill for a while then.
Yeah.
Okay.
I mean,
sure.
this has crypto in it. I would like some eyes on it.
That actually makes a lot of sense. Okay, great. Okay, thanks. I don't know. I see Jonathan. Does he have anything else? Okay, perfect. Okay, thanks everybody.
Composite keys.
Mike, composites next.
Hello. I'm going to co-present this with Max. So we're both going to be swapping slides back and forth here. So we're presenting here sort of one cluster of drafts, which has a bunch of stuff going in. So there's the composite keys and SIGs and chem, which are all sort of 3 separate drafts, although maybe merging them could be a discussion point. And then there's also a brand new one, which is the draft Pala-Klausner composite K of N, which is a 00 brand new. Isn't on the agenda, Max, but we're going to present that here too. Next. So we've done a lot of changes since 116. We've basically gutted all of them, and they're each like 80-page drafts. So yeah, work was done. The big change was that we've listed explicit pairs. So the working group in Philadelphia asked, rather than just have generic and some like, here's how you define explicits, that we should actually lay out the explicits. So we've done that now. We've expanded the list quite substantially since 116. And that was largely in collaboration with the OpenPGP guys, so that we are consistent between LAMPS and OpenPGP and which post-quantums we're pairing with which elliptic curves. In the draft, we've got a rationale section that explains, it's sort of a 5-point list of, we're taking NIST levels 1 to 3 and pairing those with 256-bit curves, and NIST level 4 and 5 you can pair to 384 elliptic curves. So if you sort of take that guidance of how we're doing the pairings and you unroll it, you get these lists here. So it's signatures 17, 14 explicits, and then 3 generics. I'll get to why there's 3 generics in a second. There are also some hash then sign variants. So if you really care about taking your message, hashing it once, and then firing that hash down to each of the composites, so it's the same hash across, we've got a variant that does that, and Max will talk about that. Chems, we've got 10 explicits and 2 generics. Well, again, I'll get to why there's 2 generics. We did a lot of work on the ASN1 modules. They are lengthy, but they now compile, and we hope that they're good. Yeah, yay. And then Chem Combiner. So I'm also submitting later this week the CFRG Chem Combiners draft, and so that's been worked backwards into this CMS hybrid chems draft, so it's all consistent and more robust than it was before. And then finally, there's this separate K of N mode draft. So we initially, the composite drafts have evolved quite a bit. There used to be OR modes in the composite draft. We were asked to take those out for the sake of simplicity and fork them into a separate draft. So that K of N mode that Max is going to present is the OR modes coming back in, but as a separate document that's essentially an extension. And if you want to forget that it exists, you can, do that because it's an extension draft. Next.
Oh, if it were only so.
I like to live in bliss. So here's my map of how all these drafts play together. So we've got a couple of drafts that aren't part of this cluster that we depend on normatively, the CFRG Chem Combiners and the ChemRI that John just presented. And then keys, signatures obviously uses keys, chems obviously uses keys. Currently we split them up. So if you just want to do signatures, you don't need to bring the ASN1 module for chems. It's why we have them as 3 separate drafts. The ASN1 modules are separable. We could jam them all together again if that makes sense, but they're all lengthy documents anyway. And then the K of N is sort of an extension of signatures. Next. Oh, sorry. Before you next, I'm going to point out on the bottom there. Max is going to present something that was tucked into K of N is a algorithm deprecation mechanism for CRL OCSP. If the CA wants to advertise that RSA is dead, Max is going to present a way to do that through CRLs and OCSPs. Next. DKG is giving me eyeballs. That's probably means something. Okay, here's the list. Here's what we've come up with. 17 signatures, all paired according to some master plan of what crypto should pair with what crypto. At the bottom, we have 3 generics. So the first one, ID-alg composite, says you take your raw message and you just hand it down to whatever your component primitives are. And then we've got 2 pre-hashed versions where you take your message, you hash it, and then you hand the hash down to whatever your underlying primitives are. And that means you know that you're getting the same pre-hash across all your primitives. So if you care about, HSM network latency or something, you might want to do that. It does, I think, mean that you sometimes double hash. Like if you hash at the composite level and then you hand it to a pre-hashed ECDSA, you might end up hashing twice. But if you chose to use that mode, that's what you get. Next. Here's the list for chems. Again, the pairings are all sort of consistent. The KMAC at the end, it represents the composite combiner, the hybrid combiner. And so we're choosing to use KMAC as the KDF here, and we're specifying 128 or 256. And there's a definition of, there's a bit more than just a single KMAC here. There's also a SHA-3 inside and some output length. So these are all sort of defined in the document, what combiner matches with KMAC 128 or KMAC 256. And then the generics, there's a generic for each strength of KMAC, depending on what you want to put into it. Okay, Max.
You're muted.
Can you hear me now? I hope so.
Yes.
Perfect. Okay, so hello everybody. I'm from Colorado. So a few things that I wanted to share with you today. Thank Mike for the introduction of and the presentation. So we work on several things. So the first thing is the hashing sign. So currently, we use, as Mike say, we use the algorithms without pre-hashing. I'm not referring to the pre-hashing in the algorithm itself. This is a hashing sign. That's what I'm referring to. There's some indications that in some environments that might be a preferred way, for performances or making sure that you sign the same data. So informal conversation that we had with NIST at the beginning of the year. They said, well, we really don't have any security concern. They mentioned they checked with the lithium team, and they came up with a proposal for SHA-256, SHA-512 for this type of signing paradigm. I asked specifically about SHA-3. They said, we are not really interested in SHA-3. This was an interesting consideration, but that's why we're actually focusing on these two algorithms. So we proposed the definition of these OIDs for the hashing sign, both for the post-quantum certificates and for the generic composite. So we defined the one for the generic composite in the draft, but the other ones are referred to in the OID mapping that we use in the PQC hackathon repository. So if you're implementing and you want to do that, there's some references there. We have actually in the repository some new artifacts that use that actually generated a Julian generated one. So there's some work going on there. So next slide. So this other topic is the K of N. Very simple. We removed the OR from the original draft. So in the composite, basically, the composite requires that all the components' signature are validated correctly. So this is sometimes in some environments, especially when you are developing, in a mixed device-based environment, and most of the time, you might have the situation where you can only validate K signatures, and that might be good enough for you. So, for example, devices might not be fully upgraded, so you have several limitations. You might switch in your migration plan. You might switch to different algorithms in midway. So you think about this as a cyclic migration, right? So many people are only focused on PQC, but in our mind, this is a very occasion to really build a crypto agile processes. So this is where we are focusing on. And then there might be some implementation issues, in some devices or others for newer algorithms. So this is all the reasoning why this might be a good sense. Now, during the transitioning period, if the K out of N really grants you the long-term confidence that you need, that's perfectly fine. So in the draft, very simply, is the same structure as the composite. It just adds a parameter that indicates how many signatures are required to be validated out of this N for the generic signature to be correctly validated. Next slide. So the draft is available. Please, if you have time, review. We're really looking forward to some more feedback. So this is a simple solution. We found a simple solution. We think so the open questions that we have, like, should we specify K? Should we specify more a structure type of data structure, like using a bitmask that indicates which ones you really require as a must validate, or a combination of the two. So for example, you have a 3-algorithm combination, and you want to say this algorithm is really required, but one of the other two can be obtained. So as Mike said, if you don't have the parameters, this behaves exactly as composite. So it's very compatible with that situation. Next slide. So last update that I wanted to bring to the group is the algorithmal revocation. So we tried. This is an issue that is on our mind, has been for quite a few years now. We try to bring it to the group, and I hope that we can start more discussion on this. So in particular, when you're using multiple algorithms in a PKI, there might be a situation where you need to revoke an algorithm, right? So today, and this can be done not only because you're using hybrid PKIs, right, composite or other type of PKIs, hybrid, but also because you're using mixed algorithms. So you start issuing certificates on a certain algorithm, then other algorithms, etc. Or you're using a combination in your infrastructure vertically. So what I'm focusing on is this type of PKIs, not the single algorithm PKI, because of the crypto dependency. Like you cannot revoke an algorithm using the same algorithm. It would be very not very very secure. But one point that is very important to make is that differently from the normal revocation use case where you have individual incidents, the algorithmic failure is a systematic issue. And because of this really impacts and the scalability issue that grows with the size of the certificate population. So we want to try to tackle this in a different way, not just using serial-based revocation. So next slide. So the idea here.
Before I advance, Max, slow down a little bit.
It's done.
Okay. So what are the considerations that we can make here, right? So there's the first consideration is we can make a new system, completely new system. Maybe there's some good consideration related to maybe we want to reinvent a revocation, right? But we have another possibility. Why don't we extend the revocation system that we have today, adding some algorithm-based revocation alongside the serial number revocation that we have today, right? This could be done very easily, like we did some tests, like doing it with the simple extensions for CRLs or OCSP. This could be, adding the list of algorithms that you shouldn't trust in that particular ecosystem, or they can be a little more complex, adding an invalidity date. But basically, this allows us to use the same procedures that we use today. Whenever we want to evaluate if an identity is revoked, we go to the revocation system. And so this aligns with today's processes, with today's automation, and can be enforced with policies, right? So if you're doing web trust audits, this all fits well into that system. So next slide. So we think that this is a very simple, scalable, cost-effective type of way to address this problem that might come to our ecosystems soon. And so we need to have some kind of approach, right? There are many different ways. This is one possible approach. So we really would like to have some kind of a collaboration on this idea to feel that, to see if we are missing some use cases that are that require a more complex solution, right? If this could cover like 99% of the of the use cases today, that would be great, and we can start deploying another system in the future if needed. That takes care of other things. So I'm looking forward for some future discussions on these three topics. Please, if you're interested in collaborating, we're very, very open to that. And with this, Mike, back to you.
Do you want to handle the questions first?
Absolutely. So,
hi, Max. This is Sean Turner.
Sure.
I appreciate you might have had a bunch of cups of coffee to stay up. I appreciate you getting it. And I might understand why you speak a little quickly. I speak quickly as well. Hey, so I was just cruising through your draft real quick, and it's an extension. And it doesn't define whether it's critical or not. Do you have any feeling for which way you think you would recommend it?
Which extensions are you talking about?
So the extension that you defined in the document that would carry these revoked deprecated algorithm lists.
Oh, right.
Defined as an extension for CRLs or for OCSP.
Correct.
Usually with an extension, right, you got to say one or the other.
Correct. We didn't think about the criticality. It depends on your ecosystem. I would say it depends on the status of your if you're trying to enforce it softly, you can use non-critical extensions, and then when you're ready to say, no, this is the time where I want to be sure everything is is rejected, then you can do critical. Well, it's something that we didn't really address yet.
Yeah, I mean, I think that there's a lot of tooling that's going to happen to make this kind of work because there's a whole bunch of people that don't like CRLs and they don't even bother to go get them, and trying to make sure that if you indicate via CRL or even OCSP that then that thing is going to get somehow talked or somehow that information is going to get piped into the HSM that's doing these checks. I don't know how that's going to, or the software. So I'll sit down. Thanks.
There are a lot of environments where the client isn't going to take crypto policy from the CA anyway, but so this is, scope to the environments that do, right?
Okay,
Like, try and keep that hat on.
That would be the power.
Paul Hoffman, I have a bunch of comments just on this part. One is it should not be in the same draft with K of N. That's like a complete layer violation. But it also should be in a separate draft because I think this one is going to take years worth of grinding on. Your statement of, oh, we might need this soon. I'm sorry, that's garbage. We don't need this soon. There's nobody who's saying, boy, I need an automated mechanism for getting rid of this algorithm. They have to do that with switches and with, issuing new certs and such like that. So we're not in a rush on it. We should do it carefully, particularly because if we do it wrong and someone hits the button, a lot of things are going to fall over and die and not be able to be brought back because we have revoked the last thing we can do there. So please don't rush this. Please do this as a separate draft. Please think about it.
Paul, thank you. Yes, I totally agree with you. Should be a separate. This might be a larger, exactly. Coming back to the comment before, if you're not using CRL or OCSP, this work doesn't really affect you. So just want to let you know if you have other ways to do it, please let us know. We would like to collaborate.
Hi, this is Daniel Lafont. So I'll log in next time. I had a question. I guess it was. Let's see if I can ask this question right. So, in the list of explicit algorithms for the combiners, I don't know if you have the slides that can go back to those lists, but if I remember right, it looked like the KDF was being done with like SHA-256, SHA-512, for instance. One of the things that I noticed there. So, I guess a couple of days ago, Dustin Moody, for instance, gave a talk where they said, they had this list here. So for Kyber, for instance, there's a Kyber 90s version which uses, for instance, like SHA-2 stuff instead of SHA-3 or Shake. They said they're basically we're not going to standardize that, but instead we're going to standardize the one that uses Shake, which means so at this point it means these constructions now have a SHA-2 and a SHA-3 kind of in the same pipeline for the algorithm, and I just wanted to kind of raise that. No particular suggestion other than to say make sure that I guess it's done in a principled way because why use.
This is all SHA-3.
Oh, it's all SHA-3. Oh, okay, great then. That's it. Problem solved. Thanks.
Hi there, Daniel Gilmore. I don't know why everyone's complaining about how fast you speak because you're still like 0.75 acres. Couple comments. So first comment. First comment is about the generic combiner OID. Can I combine the generic combiner OID with a generic combiner OID? Is it forbidden in the draft?
No recursion.
Is it forbidden in the draft?
Yes.
Explicitly forbidden in the draft.
Recursion.
How do you expect? We're talking about algorithm deprecation here, right? How do you expect implementations that don't do algorithm deprecation via whatever this additional mechanism is put together to think about the intersection between their algorithm deprecation and the variety of odd algorithms that they might get with the generic combiner? I just want to, I don't know that I'm looking for a specific answer here. I'm just pointing out that these sorts of complications are ugly and people are going to get them wrong. And defining a generic combiner, we are providing people with the toolkit of a bunch of rakes that when you step on them, they hit you in the face, to mix my metaphors. I'm not sure it's a good idea to build that toolkit. I don't know really why we need it.
Yeah, right. So it's a fair question. I think the general answer is LAMPS is defining a bunch of explicit pairs, and we're defining a rake factory OID. And if you want to be a rake factory, get off our OIDs, go to that one.
Why are we defining a rake factory?
Because I think people are going to do it, and so we might as well.
So we want to give them the rake factory? Let them build the rake factory.
Actually, DKJ, from my point of view, actually the generic one is a tool that allows me to go through several migrations as needed without the need to go back to standardizing new OIDs all the time. If we don't
Do you have an
to do
arc
that-
in the OID space?
Sorry?
Do you have an arc in the OID space? Because if you do, you can experiment as much as you like with that arc.
I'm actually moving away from just experimentation, right? So in the future, as I said, we might start with post quantum, then we might start with post AI crypto, and then there's a notion in the crypto community that there might be some crypto instability for a while, and so in order to prevent the transitioning to be costly all the time and investing, think about how many people are there just to define these OIDs, right? And avoiding this type of costs and be more agile. One of the things that I really would like to have is tools that let me be crypto agile so that I can manage my ecosystem quickly and organizing in as a whole. So for example, our ecosystem, the PKI is very well managed and controlled. So, and that is the origin of the whole trust for the whole cable industry, right? So that's what I'm referring to. Combinations for generic, I understand that you see that as being very, very dangerous if you don't know what you're doing, and I agree with you. However, it's a very important tool that I think is very fundamental in the future. This is personal.
Okay, I mean, we can agree to disagree on this, but color me skeptical that having this combiner is going to make it easier for you to rapidly roll out and remove additional algorithms. The cost of rolling out the algorithms is not the lack of an OID. The cost is vetted implementations of the component algorithms and an understanding of all the relying parties of which algorithms are acceptable or not. Those are the costs, and the fact that you can make this, it's not going to make it any easier. What it's going to do is build a rake factory, I think. So I would recommend not doing it, just so you know where I'm standing. On the algorithm revocation
Can I
front,
just throw in one comment on that? So
Yeah.
if that's the will of the working group, if we can get to that on list, that generic should be removed, happy to remove them. It's easy, couple keys on my keyboard to take them out, if that's what the working group wants.
okay. So on the algorithm revocation via CRLs and OCSP and other mechanisms, I'm wondering what you imagine the time frame is for algorithm replication. If you're following the sorry, revocation, not replication. Sorry, I'm talking at 0.5 acres, which is too fast. How long-lived are the certificates that you're imagining that are being generated? And what is the time window wherein we want to deprecate? Sorry, I'm looking at you because there's a human in the room. I tend to look at the humans. I'll look at the screen. Well, I don't know. I look at the camera. I don't know how to do this. I'm a human. What's the time frame you're imagining for the certificates that are issued? And what's the time frame for the algorithmic deprecation, right? And we're talking about like, oh, this is a psych-based certificate, and we want to get rid of it fast because we just learned that psych was a bad idea.
I actually might take a stab at that. I think, Max, what you're trying to do with this is you have an environment where it's hard to communicate with your clients, but they do respect CRL, and therefore you're trying to use CRL as a way to communicate with your clients about crypto policy.
Correct. That's the environment that we are in. So we need to coordinate across the environment. This is the trust point. The PKI is the trust point for the whole industry, and that is a very well suited way. So in our industry, we use, unfortunately, very long-lived certificates, something that I'm trying to change, but there's nothing I can do about it. Answering your question, this is more for identity long-lived certificates. Definitely, it's not a problem for short-lived certificates or certificates that are probably even 6 months in validity, because that's usually that's not the time frame that we're talking about. But I can see that totally different for our industry, where we have devices that are very long-lived type of identities.
Okay, so I'm a big fan of trying to think of new ways to deprecate old bad stuff, because we have a lot of old bad stuff out there. So, I like the idea that we're trying to figure this out, but I am not convinced that if our goal here is figuring out how to describe algorithmic deprecation that isn't somehow coupled with software updates as well, because presumably if you're deprecating algorithms, you're also trying to deploy new algorithms that you think will be adequate replacements. And if the CRL isn't going to give you a software update, right, it's going to turn something off. And so if there's policies that we want to communicate about what needs to be turned off, I'm not sure that mere algorithm identifiers are sufficient to communicate that. There may be other things that also need to be communicated. So I appreciate you're trying to do the work to do this deprecation. We need to think better about deprecation, and I love seeing proposals like this. I just am not sure that this is describing all the flavors of revocation that we might need.
Right.
So,
all right, let's move on to Yoav.
That's perfect comment. Thank you. I really like to hear your opinion on that. I just wanted to point out, if we have the possibility to do something simple and then augment it, that probably would be a great position.
Hi, you're still not getting the utility of this algorithm revocation. First, I don't think the CRL or CSP response published by the CA is the correct place to tell the clients that RSA is no longer secure. So suppose we today create a 15-year certificate with dilithium and RSA or something at RSA, and then in 12 years we decide, no, RSA is not secure, everybody can break it on their phone. Okay, so in what sense are we revoking the algorithm? I mean, are we telling the clients, don't check the RSA on this existing certificate anymore, check only the dilithium? I mean, yeah, we can do that, but that's something that the client should know and should not receive that information from the CA, but rather from the software vendor. And I just don't see the utility of the CA revoking an algorithm that it has assigned, because the RSA signature is still valid. It may not mean as much as it did today, but it's still valid. There's nothing to revoke.
Right. No, Yoav, the idea here is that, if you made the example of using two different algorithms, would be the case of, if you cannot really do the two algorithms, right, but you only can do one. At this point, and the RSA, the ecosystem decides, the RSA in our ecosystem, we don't want you to use it anymore. This is the mechanism that seems to be very easy to integrate with our current practices today. So that servers will not really enable devices that use deprecated algorithms, because that identity can be compromised all the way up, right? So especially if you're using a single algorithm. So that's the idea. And I probably coming from different point of view. I think you mentioned something, the vendor. So thinking more about the type of device certificates. This really depends on your ecosystem and your environment. You might want to use it. You might don't want to use it, depending on what your requirements are. But I totally understand your point.
Okay. You could also think of it, if you're a CA and you're about to revoke 500,000 RSA certs, it's possibly easier to do this instead.
Okay, Flo,
Correct.
and then we're going to move to the next slide.
Thank you.
I can ask in the chat, given the time.
Thank you.
Okay, I have one more slide, I think. I regret letting Max put the CRL stuff in with the composite stuff. That was a distraction. Yeah, so open questions here. We have a couple design questions. They're fairly minor at this point with the composite stuff. We do need an ASN1 adult to help us with a couple of the ASN1 problems. Is the list of pairs that we've suggested, the 12 SIGs, 17 SIGs, and 12 chems, is that too many? Is that not enough? Do we, please, now's the time. And then the last slide, I think, is, are we ready to adopt this? This has been floating around for years. Does the working group actually want this work in the end? And is it sort of mature enough to take it?
Okay, does anyone have concerns about a call for adoption in a couple of weeks? I guess I would like to see you start a thread about generic or not being included.
It's on me.
Yeah.
Russ, sorry, I didn't get the hand up, but the question of combining the three actually has a lot of effect on the call for adoption.
Indeed it does. I was going to work with the authors to figure out what the sequence is. Okay.
I want to leave them separate unless someone feels strongly about merging them.
Yeah.
So here's Guiling from Huawei International. Yeah, so I don't object to adoption. Yeah, so my only question is a technical one. So something like a half year ago, I read several of your documents about the component keys, etc. I say the idea very good. I don't give a complete review, but I remember one question is that when you do composite key, etc., like the key ID may have two ideas. One is a specific one, like, okay, I use to specific algorithm for the key or for the signature, etc. Another one is a flexible one. So the algorithm ID maybe just tell the program, okay, this is the composite key, but which specific algorithm or specific key are not specified. You need to pass the data and analyze and know what is specific key. Maybe 2 keys, maybe 3 keys, what is the key algorithm's name. So I would like to know which approach you are using now, you adopt now.
Right. So the current document specifies both. We're calling the first kind explicit and the second kind generic.
Oh, yes.
Although flexible is a good name too. We're proposing to standardize both, although there's been some discussion here about maybe we should remove the flexible one.
Yeah, I missed the message. Yeah, okay. Specify both of them now. Okay.
Currently, we're trying to specify both, proposing to specify both.
Okay.
We should talk in the coffee break. I think we should let this meeting keep going.
Yeah, thank you. Okay. Yeah, quite some technicals. Yeah, thank you.
Okay, we have 5 minutes left. I'm hoping we can do 5990 bis.
Hello, I'm Sean Turner. There's, I think, one slide, so we got to be able to do this quick.
Can we read them?
No, I sent new slides. Can you refresh?
Oh, no, I didn't load them.
Okay. Sorry. All right, so the next slide is why do we need this? Well, we got this new KM recipient info, and so this kind of backports, I guess, I'm not sure if that's the right word, the original chem, the RSA chem. And now I'm not a cryptographer. I don't know if it's a great chem or whatever, but we're just kind of dotting the I's and crossing the T's here. I do know that there was an outstanding question. The one comment we got was from Mike O, and I'm kind of putting you on the spot. I did give you a heads up, so are you okay with the suggestion that Russ made?
Yeah, I've been looking at that email, and I haven't given you an answer on list because I might have been too drunk on writing IDs at midnight when I put that question out there.
Fair enough.
I think what you have in OO is good. You're carrying the RSA chem parameters, not the generic hybrid parameters, and I actually think that is what I need. I don't think I need to carry an AES. So I actually might retract that midnight comment, but
Okay.
I need to look at it a little bit more.
Fair enough. Yeah. So the really interesting part is that we actually have a forthcoming 01 version, and Russ was able to send this to Mr. Cook, and he was able to verify it in the Bouncy Castle. So we're actually having an appendix that includes, base 64 encoding and ASN1 encoding, so people can verify it. And so the grand plan is, can we adopt it?
Call for adoption is underway. The only outstanding comment is Mike. So as soon as he answers it, we'll know the answer.
Right. Okay. And again, since Russ is a co-author with me, Tim's going to be the one making all the decisions. So, all right. That's it. Oh, I guess I should say I'm also doing a Kyber pop draft. I'm working with my co-authors. I sent it to them, I don't know, 27 hours ago, and we were having some discussions about getting a 4. So that should be popping out as well. Thanks.
Okay, we have like 2 minutes left. This presentation is pretty short.
Hi.
There he is.
Can you hear me?
I'll-
Oh,
Hey, Daniel. Yeah, I'll keep it short. Next slide, please. Yeah, so the purpose of this draft is to restrict the purpose of identity certificates to prevent misuse. The basic reason that we wrote this draft is for the 5G use case, basically, to add new extended key purpose identifiers for COSE and Jose. Next slide.
So given that we've got 1 minute, could you tell us why you need this OID?
Okay, next slide. I think that should explain why we needed that. So this was part of discussions that were happening in 3GPP. I mean, network functions in 3GPP use service-based architecture. They use TLS for communication, and they use COSE for signing and basically encrypting messages that's exchanged between network functions. And what we had realized is with virtualization and microservices architecture, there is potential chance of misuse. So we wanted to restrict the purpose of these certificates, that they don't get used beyond the purpose they're being assigned by the internal CAs. So for that purpose, next slide, please. So we have defined 4 key purpose identifiers, and I believe one of my colleagues had presented this. Next slide. Yeah, there was some discussion on whether we need 2 EKUs with key usage identifiers or 4 EKUs, and we thought it's for processing rules, it's much easier because it makes life easier to process just whether it's for JWS or JW or JWE, rather than combining that and putting in one EKU. Next slide. Yeah, this was presented in as a technical report in Athens, and here there was consensus in taking this work forward, provided IETF is interested in that. So I wanted to hear whether we believe that if it's not contentious, then we can, if we could make progress on this draft.
I think the top 2 bullets here capture the only controversial part here is to use the key usage bits to determine whether it's signature encryption, or do you do the combination into the EKU? The email protection is an example where the top approach is taken, and I'd kind of like to continue to use that. That's personal opinion. Do others have any thoughts? Silence. Okay.
I'm fine with both the approaches. I mean,
okay.
Yeah.
So why don't, if you could update the document to use that first approach, then we'll do a call for adoption.
Thanks. That would be great. Thank you.
Thank you all. Sorry we didn't get through our whole agenda. So, hey, Scott. I want to work on group chairs lunch. Yeah.
Yeah, that's where I am, Dan.
Thanks.
Nice to meet you.
No. Nope.
But just send so maybe that'll. Yeah, no, absolutely. Yeah. I might actually reach out to you because at some point I would like to actually learn more about all this stuff because he knows about it and I don't. Yeah, exactly. So I just want to understand enough so that I can sort of like from my point of view, things fall from the sky from 5G and we do stuff with it, and I don't really understand the context. Yeah. Yeah. Okay, no, that sounds great. Thank you.
There's a massive